Hello, everyone. Thank you very much for choosing to spend this next hour with us. Welcome to Onset's Thought Leader Webinar series. So today's topic is on the use of real-time water level data for wetland and stream mitigation. By the way, my name is Mamadou. Oh, I think I clicked too fast. Yeah, so my name is Mamadou, and I have the privilege of leading the HOBO product management team, and I'll be acting as your host today. Before introducing our thought leader, Bob, I just would like to go through a few webinar logistics. We are estimating it's going to take probably about a half an hour to 45 minutes to go through the material prepared by Bob, leaving us hopefully some time to answer your questions. So I'll be monitoring those questions. Please, throughout the webinar, feel free to enter those and I'll queue them up for Bob. And for anyone new to Onset Computer, Onset Computer Corporation is a leading provider of innovative sensors and data logging solutions. I'd say we're historically known as a provider of accurate and reliable data logging solutions, serving various applications, but today we'll focus on a specific one. So we've been around for a little bit over 4 decades now, and we've built a pretty strong presence in the market, and we are better known by our brand name HOBO, and we are ISO certified, and we are based here in Massachusetts on the Cape. With that out of the way, it is my pleasure to introduce to you today's presenter, Bob. So Bob is a senior project manager at Resource Environmental Solutions LLC, better known as RES, the nation's largest ecological restoration company, focused on restoring a resilient Earth for a modern world. With nearly 40 years of experience, Bob brings a wealth of knowledge and expertise in environmental studies and permitting. In addition to this overall experience, Bob brings 30 years of experience in the restoration of wetland and streams. So with that out of the way, Bob, please take it.
All right, thank you. Yeah, today we're gonna really kind of delve into real-time hydrology monitoring within a mitigation context. To get going, so I understand my audience a little, we're gonna launch a poll and kind of see who the audience is and how they are involved in mitigation efforts. I think there's
I think the poll is open. So if you guys wouldn't mind just entering and identifying yourself, please.
Yeah, so right now it's about 50% folks in the mitigation industry, bankers, ecologists, engineers, a few in the regulatory community, and about 30% not engaged in mitigation, but interested in the real-time system. Let's see, the final. So yeah, I think that's. I think we've got everybody in the, most everybody in the poll.
Most everybody. It's closed now. We can move forward.
Okay, so that kind of helps me understand the folks I'm speaking to here. Right now it is not letting me move forward. There, let's try.
Can you click on the screen? Let me see. I can try to move it for you then.
Nope, I got it rolling now. Something changed. So The agenda, just at a high level, we'll touch base a little bit on what mitigation is, how hydrology is measured, and performance criteria within mitigation, some of the challenges of the current technology and approaches. I'll touch base on sort of our search for a solution to some of the traditional challenges we've had with monitoring hydrology. Mamadou is going to step in and go over the actual technological solution Onset developed. And then we're going to come back to me and touch on what's the benefits of the real-time solution, some of the challenges of you always have when adopting new methods, and a little bit about rethinking some of the performance criteria and other ideas when you within a mitigation context. So for those, I think 35% or so of folks who are not involved in mitigation world, under the Clean Water Act, way back in the 70s, if you wanted to develop a highway, an airport, or a private development site, you had to get a permit from the federal and state agencies. That permit allowed you to impact waters of the United States. One of the to offset the impact of that development project you were going to implement, you needed to provide some sort of mitigation offset, and that could look at different differently depending on where you are. It could be you've impacted freshwater wetlands or freshwater stream. It could be a tidal wetland or tidal waters. If you're out on the West Coast or outside of the Clean Water Act, there's actually mitigation for animal species. A lot of my comments are going to be focused more on the freshwater and in particular wetlands, but if you have questions about tidal waters, that sort of thing, I'll be glad to answer them or dig into them at the end. Sort of like three touchstones that I kind of stress in looking at performance monitoring for mitigation is, whenever we talk about something new, and we want to modernize or improve mitigation monitoring, whatever we propose should be holistic and help us understand the big picture of how the ecosystem is working. It should be transparent. In other words, the data should clearly identify how the system is performing, and it should be easy to interpret. Bad performance, a site that's not performing well, should be easy to see, hard to hide. That's that transparency part. But it also, transparency is, all ecological systems change over time. It's just part of the normal process. What you need to be able to figure out, is it trending in a good direction or a bad direction? So those kind of pieces I think of when I think about transparency. And the other thing is it needs to be efficient. Inefficient sampling methods or monitoring methods doesn't provide good outcomes for anybody involved, whether it's the banker or the regulator. And so using technologies like this will help us reduce the labor involved in collecting the data, and that gives us more time to actually analyze the data. Look for better ways of presenting the data in a coherent, holistic, transparent way, and that should lead to quicker reviews by regulatory agencies. So those are some touchstones to think about. In the mitigation process, you have a performance criteria. For wetlands, wetland hydrology, you're really showing that what you've restored, enhanced, or created meets the wetland hydrology definition, kind of going back to the manual used for identifying wetlands. So groundwater would be within 12 inches of the soil surface. The site could be ponded or flooded. That needs to happen in the growing season, and it needs to happen for at least 14 continuous days in that growing season. Or this particular criteria varies by state or region. You may have a criteria that says your hydro period has to meet that of a similar reference wetland nearby. And remember that these are like broad summary of the types of performance criteria out there being used in many, many different jurisdictions. I'm sure there's others that are out there. Stream hydrology, you may have a requirement for how many times the stream floods out of its banks per year, or maybe you're measuring how much base flow you have in the stream during a year. Have you enhanced it so it goes from intermittent to a perennial flow? So those are just some very high level examples of what the measuring stick, the performance that you're required to meet. And we have to monitor to show whether or not we've met that performance criteria. For wetlands, traditionally it's a shallow groundwater well. It's only 18 inches deep or so, because we're really focused on that upper water, the groundwater in that upper 12 inches of the soil. And we almost universally use the water level logger. Onset produces the HOBO. You see a little picture there at the bottom, the little black canister. Self-contained battery data, all of that is contained, and that goes inside the well. It's programmed to capture data every 4 to 6 hours during the day. Kind of gets the highs and lows of the daily fluctuations in groundwater table. The number of wells per acre varies depending on where you are in the country and the rules that apply there. And in some sites, we have as many as 100 wells out on a site. So as you can see, that there's a lot of time and labor for installation and then monitoring over the life of a mitigation site, which might be as long as 10 years. Stream hydrology, we would put in a stream gauge built somewhat differently than the groundwater well you see in the photo. But again, water level logger down the pipe. It's programmed to capture data every 15 to 60 minutes because we really want to get the hydrograph of storm events that occur. So pretty simple set of field equipment and a very reliable monitoring device. But there's challenges in this traditional monitoring system. You have to go out to the site, as a picture here of one of our employees, where you pull that logger out of the well and put it in a data downloader or reader and transfer that data into the logger to take back to the office. That means you got to drive to the site, which many places it may be several hours. A team of 2 would go out. They may have to walk hundreds of acres of wetlands and be sure to collect all the well data and bring it back. That's a lot of time and effort. As in any endeavor monitoring, there's always potential for loss of data to user error, which always I get a cold pit in my stomach when that happens, because you're worried that it creates a trust issue with your agencies, that you're trying to hide something. And most of the time, it's something very simple. A new employee forgets to turn on or launch the logger at the office, and then goes and plops it in the ground. You don't know till 4 months later that when you pull that logger out, it was never turned on. Maybe they walked a big site and they missed 1 out of the 100 different wells that was out there. So now we're missing data, and you won't get it to the next trip out. And something that happens more than you would think is there's so the water logger measures air and water pressure. You have a barrel logger that measures air pressure, so you can subtract the air from the water pressure. Where that barrel logger, we deploy them into a tree or someplace else on site. We've lost them. People have forgotten where they put them. We've had bears eat them. You lose that barrel logger, and it compromises your ability to recalibrate the water pressure data. When you get back to the office, you got to do that air pressure compensation. You got to plot the data well by well by well. All of that is ripe for improvement. But the real challenge is it's not real-time data. You may not go out there for 3 months, 4 months, and you don't know whether the equipment is working or not. Did they forget to launch it? Did it get knocked over by a storm event? And that you're blind as to what's happening to your mitigation site. Have you had a flood? Do you have beavers, like in the bottom photo? Beavers come in and change the hydrology across the site. And in some regions, that's completely acceptable. In other regions, that creates some significant issues for their site meeting criteria, like the number of woody stems on the site and stuff. And so you need to be able to be reactive and go out and address beaver issues pretty quickly. And so that lack of ability to respond in real time to properly manage your site is really the biggest challenge of the current system. And we see things like more districts are requiring more wells. Mitigation sites are getting bigger, so more equipment out there. It's costing more for labor, for travel expenses. We're seeing more and more beaver, particularly where I am in the East Coast, moving into watersheds, damming up projects. Climate change is changing hydrology across the country, particularly here in the East. Storm intensities are getting greater, which could result in damaging storm events on a stream. Without any insight to what's going on, we may not go out to a site till several months after a damaging storm event, when we should have been out there earlier. And there's a growing emphasis on measuring processes, hydrological processes on a site, not just wetland definitions. And how could we do that maybe with a different system? So about 5 to 7 years ago, I started on, writing down, what do I want this system to really do? I know it needs to be real time. I want the data to come to my desktop so I can see what's going on at my mitigation site from my computer. I can minimize trips into the field and all the labor costs associated with that. Not eliminate, just reduce the ones that are just about downloading data. We can minimize user error, through a real-time system. We would know whether something was running out of battery or had, for some reason, was having a problem and could address it immediately. We needed a sensor just as good as the Onset HOBO that was reliable and robust, that we could put out on site for up to 10 years. That's a long time for a piece of electronics to be stuck in water. It needed to be cost effective. We can't afford, the tens of thousands of dollars that are paid to set up like a USGS style gauge system. We needed something that would be cost effective for the mitigation market. And it would be great if it would send us alerts. You've got flooding, you've got battery or equipment failures, that we would be alerted to that instead of being in the dark as we are now. And so the system would really need these 4 things. And it's really very similar to if you have a home security system. You need the sensor. You need that sensor to be able to talk to a gateway. In our case, that gateway need to be battery powered, maybe with a solar panel out there in the field, and that gateway then communicates with cellular. Data goes up to the cloud and comes back down to my dashboard. So that's what we went looking for. So we started looking for our solution, and we thought we had found it with our first startup vendor, a company that one of their leaders was right out of the mitigation industry. So he knew what we needed the equipment to do. Turned out, after investing in 4 units, they were a good they understood mitigation, they were not so good with the technology. But I knew from just looking at technology that was already out there that I wanted to develop a proof of concept for specific to mitigation, that we could have real-time data. So we invested in a Virginia Commonwealth University senior engineering capstone project, and these 3 young people put together the wireless transmitter, the gateway, and tried different sensors, and showed us that theoretically you could put together a project, a commercial product that would meet our needs. So then we went to another startup vendor and started down the road of developing a whole system. Unfortunately, they lost interest in the mitigation market, ended up in the flood mitigation market. And that's when I came to Andrew at Res and basically said, we're one of your biggest customers for hobos, I think. We're looking for this mousetrap, and we sure hope you guys can provide it. So I'm going to let Mama take it from here.
Of course. Thanks, Bob. So yeah, so really glad that, after years of working with you and RUS, that we were able to come together and leverage our technology to help you solve some of your needs and pains. So when Bob came to us, we already have the technology, I'll say, in place. Sensing is what we do. We already have the water level knowledge, but we also had already in place our HOBOnet wireless sensor network that we could leverage. That's built around our weather sensing technology. So a little bit about HOBOnet. Figure I give you a high level kind of overview of HOBOnet. Oops, yeah. So HOBOnet is a wireless mesh network system for folks that are not too familiar with it, and it is really built around 4 pillars, I'll call it. Right there, you have the range and the reliability of the system, where it allows you to cover larger areas due to the transmission range. So it is built on the mesh architecture, and what it does is ensure some level of redundancy on the way it communicates, so it can take multiple paths for the data to get back to its destination, which would be the main station or the hub that pushes that data to the cloud, as Bob was mentioning earlier. With this technology, we went with the sub-gigahertz frequency range, and what it does is it offers you better penetration through obstacles. So obviously, any type of water and metals or any of like tends to absorb frequencies, so that your transmission range can get a little bit limited. But the sub-gigahertz range is not immune to that, but at least it allows you to travel higher, longer ranges, and also penetrate through obstacle a bit better. And what's neat about the system, it also does have that hopping mechanism where the data, if you have a sensor that's maybe 5,000 feet or 7,500 feet away from the main station, it can use all the nodes to travel back through that hopping mechanism. And that data can hop up to 5 times, and you can have up to 50 sensors per system. And that's also part of the cost saving, right? Instead of having 50 cellular devices, which means 50 data plans and service plan through network providers, you only have one network provider, and you have 50 sensors that can report back. And also, we kept in mind our promise to our customers, which is around simplicity. We wanted to make sure that the system was simple. We tried to do all the hard work in the background, and I equate this system to pretty much some of these Bluetooth headphones that I have, right, where you just pair it with the main device and you are ready to go, essentially. So a little bit more about HOBOnet. So like I said, we already had this system in place. We were already providing parameters around weather, again, things you care about from a weather station, and also soil, because that's also it's a system that's pretty robust, that's used in various applications in environmental and agricultural monitoring. And the latest member to the family is this water level sensor that Bob was just speaking on. So this just shows you an example of what HOBOnet looks like, the meshing mechanism. So these are just 2 examples. As you'll see, you have your main station at the center here, and you have the other water level devices. So all of these are water level devices. And sometimes, if it's a bit far, you have an area where you don't need a water level sensor, all you need is to add a repeater. And what it does, again, it helps that data hop back to the main station. So this just gives you a visual perspective of what the system looks like. And ultimately, as Bob was saying, you don't want to be in the dark. You want to be able to have the data readily available. So once you have the system deployed, then all you have to do is use our cloud software, where you can really monitor your data. You can set up your dashboard, And if you want to even set up thresholds, right, just to make sure that you've maybe that water level has reached a specific height that's of interest to you, you'll get notification, text messages, email, or whatever that's preferable to you. And if you want to review that data in a third-party software, you can. We have APIs where you can ingest that data into your own software, or you can just do a simple export in Excel to do your review. And you can do that manually, or you can even set up schedules where every week, let's say it exports that data and you have it available in your inbox without having to do anything else. So just a quick overview of HOBOnet and HOBOlink in general. And also another neat feature is, like, if you're part of a larger organization, you can even create dashboards and have a public URL that no one can actually edit or modify, but your team and people that care can actually see that information real time and know how your system is operating. Thank you, Bob. I'll give it back to you.
All right. So there's a middle bullet in there I wanted to point out: corrected data files. That whole thing of losing the barrel logger in the woods and is gone now. With every sensor, there's a barometric air pressure sensor. So the data that comes transmitted out of the unit is already corrected for air pressure, which is such a time saver and such, just a kind of a data security issue that has really makes this product a lot better for us. Of course, I had to work to kind of sell this in a corporate business viewpoint, and so we looked at what is the labor savings of running a traditional mitigation site with the traditional manually read HOBO units versus a new wireless system. And the cost savings are significant as you get into larger sites. So this example, if I had 50 wells and I had to monitor for 10 years and I had to download 4 times a year, you're talking $24,000 in equipment, but the big ticket item is that labor, almost $200,000 in labor over 10 years. And that actually doesn't include the travel costs and labor escalation over time. And so this is a pretty conservative estimate. The new system, yeah, it cost, you can see the red number there, almost $15,000 in additional equipment cost, but that's hugely offset by the labor savings. If I can go out one time at the beginning of the growing season, make sure the well's functioning, the electronic equipment is in good repair, then that should be the only trip I need in a year, and that really reduces your labor costs here. In this case, we're talking $130,000 in labor savings, or a 60% cost and overall cost of monitoring this one parameter at this mitigation site. And so, the benefits: reduce labor and travel cost, greater insight into site conditions, and that reduces risk. If a storm happens that we think could have damaged the site, we can be out there early and see what we need to do to keep it from getting worse. Or if beaver move in, or there's all kinds of things that can happen on a site that we're not having insight in there helps us better manage sites. We think it'll help improve trust with agencies, because a lot of the human error and data loss is eliminated through this system, and it can help us. We can take that labor that was driving and walking around a site and now put it to more productive use, analyzing the data instead of just collecting it. I think that in itself will change how we look at this kind of mitigation data. So what are the challenges of, and I put it in quotes, new monitoring technologies? Because really, we just married a couple of technologies together that have been out there all the time. The traditional water level logger and wireless sensor technology, which has been around, for decades actually. We just married them together. So what are some of the things we need to think about? One is building trust with the regulatory agencies who approve mitigation programs. mitigation sites. And I think, the data loss is greatly reduced from accidental loss or loss of the barrel logger, missing a sampling, etc. The network notifies us if a sensor is not transmitting so that we can take immediate action. And if a logger is not transmitting, it doesn't lose that data. That's an important part. It can store up to 6 months worth of data while it continues to try to communicate. An example where it might lose communication very shortly is after a rain event. You've got all that water in a tree canopy. That water absorbs the radio signal. As that site dries out, that signal may pick up again and make a connection. And so it's not going to lose any data during something like that. It'll hold that data till it remakes that connection. And as Mamadou had mentioned, if we put everything out there and we find that a sensor is not connecting reliably, we can throw a repeater out there. And you can do this during deployment because you can see the mesh network forming. And so it's things that we can address pretty quickly. Once that data, like I said, once that data gap is corrected, then the data is uploaded. I think it opens opportunity to rethink our performance criteria for hydrology. My personal feeling is you only need one well inspection a year to maintain it. It definitely needs to be maintained every year, but you don't need multiple trips out there. I know that requirement varies from place to place, state and core district over the country. I think we can look at different ways of thinking about performance criteria. Instead of just meeting a definition or the hydro period of a reference wetland, we can talk about things like extending duration of base flow in a stream, or extending the duration of saturation on a site. Maybe start looking at the data in plan view across a floodplain, across a wetland, and creating heat maps with the data. Things, taking that labor that was used for collection and use it for more informative ways of interpreting the data. You can even look at things like vernal pools where you want them to be wet in the spring for amphibian habitat, but you need them to dry up so they don't support fish, which would predate the amphibians. You can now confirm that in real time for these vernal pools. And if you need to go out and sample, let's say endangered species like they do in California in vernal pools, you know when to go out and do that sampling because you have real-time data coming in. And something we haven't even touched base on is like all the loggers also collect temperature data at the same time for correcting the water pressure. But there's all kinds of potential uses of temperature data, particularly in stream gauges. So one of the big barriers to any sort of change in monitoring programs is a mitigation banking instrument. For those who are not familiar, every core district, most of them have a standardized mitigation banking instrument. That's the legal document. It's often up to 90, 100 pages that sets out how the bank operates in very detailed language. Modifying a standard mitigation banking instrument can often lead to project delays with multiple meetings and explanations. And those delays can translate into hours and dollars for the banker. And moving to newest technology shouldn't really should not be inhibited by the NBI modification process. And so when I look at a technology like this, we know real-time data will give us a greater insights to how the site is performing and allow us to do a better job with adaptive management. And the outcome on that site should be better than when we are running blind with the hydrology and can't do real-time adaptive management on a site. I actually believe maybe the Corps should incentivize the use of real-time data, by either requiring fewer wells or fewer visits, or even allow some flexibility performance criteria in exchange for that ability to have that eyes on your site at all times. Data delivery is every year we have to submit data reports showing how our site met all kinds of monitoring requirements from vegetation on down to the hydrology. And a typical approach is that plot you see there in the green is the water level in a well. The blue lines are the rainfall for that particular day, documenting how one particular well met its performance criteria. But multiple plots of wells across the site don't really provide you that visualization of the data in 2 dimensions across the site. And so here's an opportunity to take time and effort that is originally allocated for collecting data in the field and explore new ways of visualizing the data. And if agency personnel want to get really detailed data like is presented and contained in this plot, we can give agency access to the actual data in the dashboard if they want to drill down and look at things in detail. And that kind of wraps us up. If you have any questions, I've got my email there. Andrew is there. So let's see if there was any questions.
Yes. Thank you, Bob. Thank you again for this presentation and for sharing your expertise. So we actually have some questions. Some I'll send your way and some I'll try to answer.
Okay.
The first question is around, I guess, the technology, I'll put it that way. So it's saying that USGS has had real-time stream gauge data for decades. Why did it take so long for this technology to show up in mitigation?
The missing link really was that wireless transmission. Mamadou mentioned it, that a sub-gigahertz radio signal that pushed the data from the sensor out to the base station that had the cellular connection. Mitigation is not as big a market maybe as agriculture, or I know a lot of that same technology is used in data centers and all kinds of industrial applications. And so I think it was just kind of waiting for our time to get enough attention on the mitigation market to marry those technologies together. And that's what was part of my struggle in trying to work with the engineers at the engineering colleges. I knew all the pieces and parts were out there. They showed it could work together. We eventually came to Onset, and I think you guys kind of had it on your horizon, but kind of reprioritized your product line.
Yeah. No, of course, yeah. Thank you. Yeah, like with everything, it I guess wasn't its time yet. So glad to have it available. A second question, and I'll maybe answer part of it and see if you want to add a comment, is around the data management side. So the question is, what does the data management side look like? One of the struggles we ran into is spreadsheets bogging down at a few years into a project because there is so much data. Maybe I'll try to answer the technical piece of it, for lack of a better word. So at least from the system, how this system is built is all this data is stored in the cloud. And you can store and have up to 10 years of data available. And in general, from accessing that data, as you're exporting those files, you actually don't have to export all that data, if I'm not mistaken. Correct me if I'm wrong, Bob, depending on how you do it. But you can actually set up a time frame that you wanna download the data, so that you don't really have to access all that data. But at least from a historical perspective, that data will be stored in the cloud, so you can choose kind of what matters to you, the data you wanna pull. And I'll maybe have you comment on that, Bob.
Yeah, and we've had the same sort of issues occasionally when we're trying to keep the whole historical record together in an Excel spreadsheet so that we can look at it over time instead of going back to the dashboard. And I actually think that's sort of the next generation of innovation We're looking internally at ways of better managing that stream of data as it comes in, especially as mitigation sites get bigger and we got 100 wells on a site, and we have maybe as much as 10 years of data. That's a lot of data points, and Excel isn't the ideal platform for that. So I think that's actually the next sort of forefront or frontier is in figuring better ways to manage the data and then visualize it. I think there's a lot better ways we can visualize the data than the traditional plot. The traditional time plot shows we collected the data and shows exactly, how many days of saturation or meeting the criteria we have, but it doesn't give you a lot of insight in how the site is performing across space or time, except one plot at a time. So I think that's actually sort of where we've started an internal work effort to kind of tackle that next issue.
Awesome, great. I'll touch on a couple here real quick for clarification. So question from Gregory. So the hub station is the only station with a cellular connection. That's correct. So only the station. So you have one single point to push that data to the cloud. The rest is just a radio, like radios communicating between each other. A couple more questions. One is around HOBOnet, if it can be deployed and used in Mexico. Yes, it can be used and deployed in Mexico. We actually have in agricultural application quite a bit of systems deployed in Mexico. And kind of connecting into another question around frequency ranges. So as far as each country definitely does have frequency ranges that you can use. So we have few options. So essentially we've used that, I think it's referred to the international region map, and each regions or sets of countries have frequencies where you can use such system. So some of the options we have range from about 860 megahertz all the way to 925 megahertz. It is not configurable, but what it is we have a list of countries where we are certified, where this product is certified to be used. So as you work with us to select a system, we'll just help you figure out which is the options that you can use. So we have 4 standard options that I would say meet the needs of probably 90% of the countries we serve. Let me see. I know we're against time here, Bob. Bear with me. I'll maybe grab a couple more questions.
Yeah.
I think we've answered kind of the questions around data management. So one question is around what did you? So it's around the hopping mechanism and the distance. So RF is a bit funky, I like to say no two system will operate the exact same based on the environment they are at, but a conservative way we spec this product is that, the hopping from a device to another is about 1,500 feet or about 600 meters, but it does require some level of line of sight. So there, what we definitely recommend is to have some of those repeaters handy, so that you can use those as a hopping mechanism to help you ensure that that data gets back. So I would say, the strength of this system is around that redundancy, where you can provide multiple paths for the system to get back to that main hub. So I would say, depending on the area, you can definitely stretch it to a radius of, let's call it about 7,500 feet. But in general, I recommend having some of those repeaters to help with that hopping mechanism. Maybe a question for you, Bob. How do you view the system as far as what it covers and comfort around reliability?
Yeah, Andrew gave me some insight on it's actually a site that we don't own, but in Georgia, where they found that it's in a pine plantation, and so when the trees are 5 to 10 years old, and most of that vegetation of that young pine is right in that the height off the ground is right in the same area you're trying to transmit your signal, that's the kind of the worst case. And they're still getting like 1,000 foot in that worst case. If it's right after a rain event, it's going to absorb more. When it dries out, it transmit, the radio signal can move through that canopy. As those trees get older and that canopy gets higher and higher off the ground, then transmission continues to improve. So I think it's one of the things, kind of think about your site. If you're in a mature forest where the canopy is well above where your transmitter is, that's pretty good. If you're in a really thick, maybe one of the coastal systems that have a very thick shrub layer, that's going to be more difficult, where you have water, have all the leaves right in the same transmission area. So something else I was going to just mention, the slide I have up right now kind of shows typical installation. And on the left slide, you can see how far up our little transmitter is on top of the white pole. That site actually gets 4 feet of flooding a year. So we had to make sure that our transmitter was above that flood elevation. And we also use this bright yellow cap that Onset provides that actually has a port for the cable to come out of, and so that's very very helpful to have a custom made well cap that fits our needs there.
Yeah, absolutely. And thanks for pointing also the height of that receiver, the communication piece. So when we talk about that 1,000 to 1,500 feet, that assumes that that transceiver is at a height of about 1.8 meters or 6 feet. And I like to say height is your friend. Actually, the higher you have it, and the further away you are from the ground, because actually the ground does absorb quite a bit of that radio communication. The higher it is, the longer range you will get as well. So that does help. So we have a few more questions. One of them is around what's the rough cost for the system? I know you gave the example of a side-by-side, let's say, a 50 well system.
Yeah, so yeah, I would say.
Yeah.
Let me just.
Yeah, sure. I think that's a good side-by-side example. Yeah.
Yeah, so we have. You might want to speak to the cost of the hardware.
Yeah,
in this system, 50 wells, each with a wireless transmitter plus the base station, comes out to be around 24,000. I mean, 38, 39,000, maybe with a few extra repeaters in there for good measure. Maybe it comes out to closer to 40.
Yeah. Well, yeah, I would say to your point, yeah. So the main hub, the station, I think the cost is about, let's call it 1,000. I would say just about every sensor you add to the system, let's call it, will cost you probably about $900, $800 to $900. So I would say the main station about 1,000, and any other level sensor you add to it will cost you less than 1,000. So that's one quick way of estimating it.
Yeah.
You can use. So few more questions that that I'll take on offline and try to answer. I want to be respectful of everyone's time. I know we are 5 minutes over. Again, Bob, I really appreciate you taking the time to do this Thought Leader webinar with us. It's been very insightful. And to the audience, thank you for choosing to spend this hour with us. Your presence here means a lot. I know you could have chosen to spend this hour in other ways, so truly appreciate it. Bob, thanks again.
Appreciate it, man.
And hope to do it again.
All right.
Thank you, everyone. Be well and take care.